Welcome to the Deep Dives. We're here to unpack complex ideas, pull out those golden nuggets of insight just for you. And today we are taking a really fascinating plunge into, well, the cutting edge of AI development. Our sources, well, they're excerpts from a conversation with some experts at Y Combinator. They're pulling back the curtain on what's really happening inside the best AI startups, specifically around prompt engineering. So our mission here is to arm you with, practical tips and just a clear understanding of this whole new frontier. It's a field that feels, as one expert actually put it, a bit like coding in 1995. Brand new. The tools are still developing, but surprisingly, it also feels like learning how to manage a person, really figuring out how to communicate what the AI needs to, well, make a good decision.
Yeah, and what's fascinating here is seeing how these leading companies are treating prompt engineering. It's not just a technical exercise for them, it's really core intellectual property. So we'll be exploring how they build their agents, how they refine their prompts, even how they think about the business opportunities in this space. It's moving so fast.
Okay, let's unpack this. A concrete example might help.
Huh.
We've got insights from a company called Parhel. They're doing AI customer support for some really big names in AI companies like Perplexity, Replit, and Bolt.
Mhm.
So their AI agent is literally responding to customer support tickets for these major players.
Right, and what's really interesting here, quite generous actually, is that Parhel open sourced the actual prompt that powers their agent. Now, this is a rare opportunity because usually these prompts are, well, they're considered the crown jewels of a company's IP, very
Right.
closely guarded.
And the first thing that just jumps out is that this prompt is long. I mean, really long. We're talking 6 pages of detailed instructions. 6 pages. That tells you something. So what does all this detail, this length, actually mean for building effective AI agents?
Well, yeah, it raises a big question. What are the sort of key things the best prompts really start with? What makes them work? First, they set the role for the LLM very clearly. Like you are a manager of a customer service agent, and then bullet points about what that actually means, what it needs to do. Then they clearly define the task, something specific like approve or reject a tool call. This is important because it's often coordinating calls from other agents. It also outlines a high-level plan, usually broken down step by step, step 1, 2, 3, 4, 5, very clear. And crucially, it includes important things to keep in mind, uh, like instructions not to go weird into calling different kinds of tools, basically stay on task. It also specifies how to structure the output. This is vital for integrating with other systems, other agents. It's almost like a gluing API calls together. So maybe accept or reject in a very specific format. And you see the best prompts using a kind of markdown formatting style heading, sub-bullets, just makes it much clearer. And a really big thing is they outline how the model should reason about the task. And often this includes giving it a really good example.
Okay, now here's where it gets really interesting for me. The example itself, it looks more like, I don't know, programming code than just plain English. It
Yeah.
uses this sort of XML tag format.
Yeah.
Why is that?
Yeah, that's a great observation. It turns out that a lot of these large language models were actually post-trained using that kind of XML type input. So that structure just makes it much, much easier for them to follow the instructions accurately. Leads to better results, basically.
Right. So what this means for you, the listener, is that this example really shows the depth of detail and the specificity that's needed to guide an LLM effectively. It highlights that crafting these prompts is fast becoming its own, specialized discipline. It's not just writing anymore. But it's not just about a single prompt, right? Even a super detailed one. There's an emerging architecture, sort of a structure, for how companies manage all these instructions.
Exactly. There's this concept defining prompts in roughly 3 layers. First, the system prompt. Think of this as defining the high-level API, sort of operating rules for how your company's AI works. That Parhel example we talked about. That's a system prompt. It has nothing specific to Perplexity or Bolt in it. Then there's the developer prompt. And now this wasn't in the Parhel example they shared. This layer adds the customer-specific context. So, for instance, how to handle, say, RE questions, that's retrieval augmented generation, how to handle those differently for Perplexity versus how you'd handle them for Bolt, customer-specific rules. And then finally, there's the user prompt. This is the direct input from the end user, like what you might type into a product like Replit or Zero, something like, generate me a site that has these buttons. Parhel doesn't really have a user prompt because its product isn't directly used by an end user like that. It's interacting system to system mostly.
Okay, so this layered architecture, it makes sense, but it immediately brings up a challenge, right? How do you build a general purpose product when every customer has slightly different workflows, different preferences?
Hmm.
How do you do that without basically becoming a consulting company, just building custom prompts for everyone?
That's the million-dollar question. And what's fascinating is that this exact challenge, it's creating huge startup opportunities, particularly in building tooling around all of this, especially tools for automating the creation of those high-quality worked examples we mentioned. Those examples are just crucial for improving prompt quality.
Yeah, that makes sense. And this is actually a great segue into something else we're hearing a lot about from top AI startups, metaprompting. It's a really consistent theme.
Meta-prompting. So basically, it's where one prompt dynamically generates better versions of itself. It's kind of meta, as the name suggests. There are a couple of techniques here. One is prompt folding. Tropier, a YC company, found you can take an existing prompt, you feed it examples where it failed, where it messed up, and then you just ask the raw LLM itself, hey, help me make this prompt better. And it works surprisingly well. The theory is the LLM knows itself so well. Another approach is using hard examples. So for really complex tasks, companies like Jazzberry, they feed the model a bunch of really hard examples. Things like finding an n+1 query error in code that's a tricky database issue that even the best LLMs can struggle with. This helps the LLM learn to reason around these complicated tasks when just writing instructions in prose isn't really enough. It's almost like unit testing for programming, but for prompts.
Okay, so what this really means for you is that metaprompting allows for this kind of continuous improvement, this specialization of AI agents. It makes them more adaptable, more capable of tackling harder problems without someone needing to constantly tweak the prompts by hand. The AI sort of learns to improve itself. Okay, but let's talk about a big issue. Hallucinations. LLMs sometimes just confidently make stuff up, telling you what they think you want to hear, even if they don't actually have the information. How do you deal with that?
Yeah, that's a persistent problem. And how do you deal with it? Well, what's fascinating here is that you absolutely need to give the LLM a real escape hatch. You have to tell it very explicitly, look, if you do not have enough information to confidently say yes or no or make a determination, do not just make it up. Stop. Ask me.
Right. We even developed a slightly different approach internally at YC, where the actual response format allows the LM to kind of complain back to you, the developer. It can basically say, hey, you've given me confusing information here, or this is underspecified.
Exactly. And connecting this to the bigger picture, we call this the debug info parameter. It literally becomes a to-do list for the agent developer. The AI tells you what needs fixing in its instructions or context. Right. It's kind of mind-blowing how effective that simple mechanism can be.
So for you, maybe just playing around with this on personal projects, a simple way to start with metaprompting is this. Give the LLM the role of an expert prompt engineer. Tell it its job is to give detailed critiques and advice on prompts. Then just give it your prompt. It'll spit back a more expanded, probably better prompt, and you can just keep running that loop, iterating.
Yeah, that's a really common pattern, especially for companies needing quicker responses. They'll do that meta-prompting, that refinement loop, using a bigger, slower, maybe more powerful model like Claude Opus or GPT-4. They use the big model to perfect the prompt. Then they take that refined prompt and use it with a smaller, faster, distilled model, something like maybe Haiku for actual production use. This is especially critical for things like voice AI agents where latency, that response time, is absolutely crucial. You need it to be fast.
That makes sense. And another practical tip, as your prompts inevitably get longer and more complex, treat them like a working document, a living document. Just note down issues you see, maybe in comments within the prompt itself. Then you can feed Gemini Pro, say, your notes plus the original prompt, and just ask it to suggest edits. It actually works quite well.
Which brings up the question, how do you really debug these things when they go wrong? The thinking traces available in models like Gemini 2.5 Pro are incredibly important debug information. They let you literally watch the reasoning trace step by step in real time. That's invaluable for figuring out, okay, where did it go off track and how can I steer it back?
Right. And what stands out here is you don't always need fancy, complex tools for this. You can even just drag and drop, say, JSON files. That's just a structured data format directly into chat interfaces like gemini.google.com and see these reasoning traces visually. So the takeaway, mastering these debugging and metaprompting techniques is really key if you want to build more reliable, more sophisticated AI agents. It's about iterative improvement. Now, for over a year, maybe more, we've been hearing experts say that evils are the true crown jewel for AI companies. What exactly does that mean? Why evils?
It's fascinating, right? And it connects back to Parhel. Why were they willing to open source their prompt? Because they don't actually consider the prompt itself the crown jewel anymore. The evils are the crown jewels, the evaluation criteria. Without those evils, you simply don't know why the prompt was written that specific way, and it becomes incredibly hard to improve it or adapt it meaningfully.
That's interesting. So the prompt itself, even a six-stage one, isn't the main IP asset, but surely there's value in that specific wording, that structure.
Oh, absolutely. There's value in the prompt as a product of the process. But the real defensible moat, the core IP, is in the process of creating and refining it, which is driven by the evils. And if you connect this to the bigger picture, these evils aren't just, technical benchmarks checking for accuracy. They're deeply, deeply rooted in human understanding. You can't really get the right evil, the truly meaningful one, unless you are, as someone put it, sitting literally side by side with people who are doing X, Y, or Z knowledge work, like that example of a tractor sales regional manager in Nebraska.
So it's about that deep, almost ethnographic understanding of the user's world.
Exactly. Your job as a founder building this stuff is to understand that user better than anyone else. And then you codify those in-person interactions, those specific workflows, those little nuances into very specific measurable evils. That is the real moat, making the software work brilliantly for those specific people in their specific context. It's about being maniacally obsessed with the details of the regional tractor sales manager workflow.
That obsession, that deep user focus, leads directly to this powerful concept. Founders today need to be forward-deployed engineers. That term, it traces back to Palantir, right?
That's right, Palantir. Their core thesis way back when was that the absolute top computer science talent. They weren't sitting inside government agencies or big Fortune 500 companies, but those places had these huge multi-billion-dollar problems, often drowning in data. So Palantir's solution was to send these forward-deployed engineers, top technical talent, to sit right next to the actual user, like an FBI agent investigating domestic terrorism, for example. The engineer's job was to truly understand their existing, often messy, file cabinet and fax machine workflows.
And the goal then was to take those messy real-world processes and convert them into clean, intuitive software. To make something incredibly complex like that investigation feel almost as easy as taking a photo of your lunch on Instagram.
Yeah, exactly. And what's really compelling and different is that Palantir sent engineers, not traditional salespeople, to do this initial work. So instead of these long, drawn-out 6-month sales cycles, they'd often have, okay, we built a prototype meetings within days or weeks, getting direct, live feedback from the user. That rapid iteration, showing powerful software that's clearly built around their needs. That's how a small startup can potentially beat huge incumbents like Salesforce or Oracle. It makes users feel super heard and seen.
Right. And this model, the forward-deployed engineer model, where founders immerse themselves in the user's world, this is precisely why we're seeing vertical AI agents focused on specific industries or roles taking off so quickly right now. Founders, even if they aren't maybe natural salespeople, are forcing themselves to be these forward-deployed engineers. They're sitting with the end buyers, they're absorbing the context, stuffing it into prompts, building evils, and then rapidly coming back with really impressive demos.
Absolutely. We've seen this firsthand. Companies like Geiger ML, they specialize in customer voice support. Or Happy Robot, building AI voice agents for logistics brokers. They're closing significant deals, 6, even 7-figure deals, often by physically going on-site, sitting with the users, tuning the software right there, and delivering these demos that just create an oh wow experience, something the big, slow incumbents often can't match.
Okay, and then things get maybe even more interesting or perhaps more nuanced. It seems like each LLM model has its own kind of personality. And founders are realizing you might go to different models for different kinds of tasks, almost like picking the right person for a job based on their traits.
Yeah, that's definitely a thing we're observing. There's a fascinating contrast people talk about. Claude, for example, is often seen as, well, more happy, maybe more human steerable, easier to guide with natural language. Llama 3, on the other hand, people say it needs a lot more steering. It's almost like talking to a developer, maybe a bit rougher around the edges, but potentially very steerable if you're really good at crafting those precise prompts.
Huh? We've even seen this ourselves internally when using LLMs to help founders figure out which investors they might want to take money from. We use these numerical scoring rubrics to try and evaluate the fit.
Right, and while using rubrics is definitely best practice for consistency, they're never perfect, are they? There are always edge cases, exceptions. So the interesting question becomes, how do different models handle those exceptions when applying the same rubric? We found, for instance, that when given the same rubric, GPT-4 tended to be very rigid. It stuck very heavily to the rubric, penalizing anything that didn't quite fit, almost like a soldier just following orders precisely. In contrast, Gemini 2.5 Pro is actually quite good at being flexible. It would apply the rubric, sure, but it was also able to reason through why someone might be an exception, or why a score maybe should be pushed positively or negatively, even beyond what the rubric explicitly suggested. It acted more like a high-agency employee, someone who can think critically and apply judgment.
That's fascinating. So GPT-4 as the soldier, Gemini 2.5 Pro as the high agency employee. Are there situations where you'd actually want the soldier's rigidity? Maybe for compliance tasks or things that absolutely cannot deviate, even if it seems less, adaptable.
Oh, absolutely. That's a great point. For tasks where you need extremely strict adherence, where there's zero room for interpretation, and where any kind of creativity or flexibility would actually be a problem, think about certain kinds of legal compliance checks or very, very specific data validation rules. In those cases, yeah, the soldier model's predictability and rigidity might actually be exactly what you prefer. It's really about picking the right tool or maybe the right personality for that specific job.
So the clear implication for you working with these models is that it really is like training a person. You give them a rubric, a guideline, but you also need them ideally to think deeply about the edge cases, to apply some judgment. Understanding these model personalities really helps you pick the right AI tool for the task at hand.
Exactly. And connecting this back to the bigger picture, it just underscores that initial analogy we started with. Prompt engineering really does feel very much like learning how to manage a person. You're communicating what they need to know, how you're going to evaluate them, and you're expecting them, increasingly, to handle nuance and exceptions intelligently.
Which, funnily enough, brings us kind of full circle back to that concept of Kaizen, the Japanese manufacturing idea where the people actually doing the work are the ones best positioned to improve the process. That's essentially what meta-prompting is doing, right?
Yeah.
Empowering the AI agent itself to participate in its own improvement.
Yeah.
Wow. Okay, this deep dive has really shown us, I think, that we're truly in a brave new world with AI agents and prompt engineering. It's moving so fast from those meticulously crafted, 6-page prompts to AI models that can actually help debug themselves and founders embedding with users like those forward-deployed engineers. The landscape is just evolving at incredible speed.
Yeah, we've definitely seen how understanding not just the core technology, but also those intricate human workflows, and even, as we just discussed, the distinct personalities of the models themselves, all of that is becoming crucial for building AI that's truly impactful.
It really is a powerful blend, isn't it?
Yeah.
Technical ingenuity combined with this deep empathy for the end user. We really hope this deep dive has given you a shortcut to being well-informed. Hopefully with some surprising facts, some practical tips that you can actually go out and apply.
Yeah, and we really encourage you to explore this further. Think about how you might apply that forward-deployed engineer mindset, even just observing a problem in your own field. What specific workflow could you potentially understand better than anyone else? And how could an AI agent, tailored with that really deep insight, maybe transform it?
We honestly can't wait to see what kind of prompts you come up with. Until next time on The Deep Dive, keep digging.